Hello everyone, welcome to another class with Professor Choi. Today we are continuing our discussion about continuous probability distributions. So this is part of my statistics teaching. Alright, so continuous probability distributions, this is our third video on the same topic. Alright, now normal probability distributions are the ones that we're going to talk about today. And again, you need to follow the videos in a particular order, so this should be the third one on continuous probability distributions. Normal probability distributions are more of a family of distributions. They're not one. They have different shapes. So basically, they depend on the mean and the standard deviation. When you have similar means, for example, so imagine that you have a center at 60, but you have a different standard deviation, a smaller standard deviation means that the normal distribution is steeper. It looks more like that. And then a larger standard deviation means that the distribution is flatter. If you have a different mean, what it basically means is that you're different from the previous one. So this one with 70 and 5, for example, will be here next to this one, and it will be like this. So in order to find probabilities on all these different distributions that comprise what a normal distribution is, we need to be able to standardize it. And when we do that, we have to follow this formula. So you can turn any normal distribution into what we call a standard normal distribution. Any distribution can be converted. So any normal distribution can be converted into a standard normal distribution by using this particular formula here. Now, the best way to work this out is by creating a problem and walking our way through it. So let's come up with a problem. Let's say that grades in a class follow a normal distribution. With mean of, let's call it 64. That's kind of low for a mean. 75, it's a better mean. And standard deviation of let's use 7. Yeah, 7's okay. Alright, so every time you turn any distribution into a standard normal distribution, what you're basically doing is you are turning it into a distribution with whatever mean and standard deviation it has into a distribution with a mu of 0 and a standard deviation of 1. Okay? So in order to turn this into a standard normal distribution, we have to do the z, not of these values. So these are basically, this is our distribution that we got. So this is our mu is at 75 and our sigma is at 7. All right? Now let me transfer that formula over here, because we're going to have to use it a lot. So z equals x minus mu over sigma. Alright. So let's come up with a question. Imagine that somebody asks you, what is the probability? Let's call this question number 1. What is the probability that a student scored 80 or higher? So what's the probability that a student scored 80 or higher? Alright? Just trying to get my water over here, you know, get a little thirsty. Alright. So, what's the probability that a student score 80 or higher? Okay, so every time I'm trying to answer these questions, I like to kind of draw my graph because it's a little difficult to just keep all this stuff up here. So you draw it, you do it nice and slow, and that's what we're going to be doing. So this is what I got right now. I know that the grades in the class follow a normal distribution, so I know how the normal distribution looks. I know that the mean is at 75 and the standard deviation is at 7. So we have our mean at 75 and our standard deviation at 7. I also know that as soon as I transform that into a standard normal, it's going to become a distribution with a mu of 0 and a sigma of 1. Alright, now, in order to solve this problem, the first thing that I need to do is I need to standardize that 80 as well. And that 80 now becomes in my formula x, because the mu is already 75 and the sigma is already 7. So, in order to calculate the z of 80, that's going to be equal to 80 minus mu, which is 75, divided by sigma, which is 7. So that's 80 minus 75 divided by 7. So 5 divided by 7. And that gives us 0.71. Alright, now, what exactly is the 0.71? Well, this 0.71 represents z of 80 in a normal distribution. So over here is the number 80 on the distribution that we have here, and then the number 80 represents 0.71 on a standard normal distribution. Okay, now to the question. So the question is asking, what is the probability that a student score 80 or higher? Alright, so it's asking you, what is the probability that a student score 80 or higher? So what is the probability that somebody is on this part of the curve? Alright, now here's where it gets a little tricky. In order to find this probability, I kind of need to know what the probability is under here. Now, if this was like a straight, like an easy number, because it would be like 1 standard deviation away or minus 1 standard deviation away, then I could use the empirical rule. But in this case, that is not so. So, I'm going to need to use some other help. Now, these tables are available anywhere online, but if you're in my class, I gave you one. You just got to find it, right? I call it formulas and tables, and you should find this document. Now, what you need to do is you need to find a normal distribution curve, something like this. All right? Where it shows you the probability of the area under the curve for a normal distribution. Usually these are called z-tables. They're called z tables. Okay? And the reason they're called z is because z is what we're using here. Okay? This is called the z, or the normal standard distribution. Okay, now with this 0.71, using these tables, we can find these probabilities. Alright? So this is the z of 80. Now, all tables are not exactly the same. So you need to figure out what table you're using. The particular table that I'm using gives me, it always gives me the same probability, okay? It gives me always the probability between the center and whatever number I gave it. So in other words, if I look for this 0.71, it is going to give me the probability between the center and that 0.71. That's what's on this table. Okay? So, in order to find the probability of 0.71, I gotta go to the top of the z here where it says 0.7, and then I'm gonna slide to this way to 1. and the answer is 0.2611. So again, to find this 0.71 on my table, I'm going to go down to 0.7, and then I'm going to go sideways to 1. So it's 0.71. That it will be there. Now whatever number is here is in this particular table the probability between the center and that number. Alright, and the answer in this case, 0.71, the probability is 0.2611. So 0.2611 is the probability between the center and 0.71 on the standard normal distribution. Now, unfortunately, that is not what the question is asking me right now. So, in order to figure out the answer to the question that we have right now, we need to do a little bit more math. We know that in a standard normal distribution, to the right of the curve, you're going to find 0.5% of the answers. To the left of the curve, you're going to find 0.5% of the answers. Now in this question, they're asking us for this portion here. So I'm going to call this portion x. But look, I know the answer to all the way to the end here. I know the answer to that little section. So I can find this x by basically doing 0.5 minus that number. So the answer to x, in this case, the answer to my question is 0.5 minus 0.2611. And that's going to give me 0.2389. And this right here, my friends, is the answer to my question. What is the probability that a student score 80 or higher, making these assumptions, is 0.2389. Alright, let's take the same problem, ask a different question. Good so far? There you go. Remember, this is a video. You can always go back. Okay? So, alright. Example number 2. What is the probability that a student scored 60 or higher? Okay? Now, as I mentioned, every time you're doing one of these examples, it's very useful to draw the graph. So let's draw the graph. And again, drawing the graph is just to visualize what you're trying to do. Now I know that the center of my graph is at 75, that's my mu. And I know that my standard deviation is 7. I also know that as soon as I z those numbers, I'm going to get mu of 0 and sigma of 1. Alright. Now, the question they're asking us is, what is the probability that a student scores 60 or higher? Now 60 is to the left of 75. Think about that way as being positive infinity and this would be negative infinity. So 60 is to the left of that 75. That's where 60 is. And the question is asking us higher than 60. By the way, I just noticed that green is not a very good color for this. So, what is higher than that? What is the probability that somebody scores 60 or higher? So, the question is asking us the probability of all of that plus all of that all the way to the inner curve. Okay. Now, in order to find the z-value of 60, I got to follow this formula. So, the z-value of 60 is equal to 60 minus 75 divided by mu, which is 7. Okay? So we have negative 2.14. Good so far? Negative 2.14. Alright, now, the negative sign in this case doesn't really mean that this is bad. It just means that it's to the left of the center. Okay? So when you get a negative z, it just means that you're left of 0. And when you get a positive z, it means that you're right of 0. So this 60 is negative 2.14. Okay, now, as I mentioned, to find the probability under the area of a normal z curve, you need to have one of these tables, or you got to know how to use Excel. You can do it on Excel. Okay? But if you don't know how to use Excel, you can use these tables. Now, this table in particular that I'm holding will give you always the probability between the center and whatever number you're looking for on the z value. So, in order to find the probability between 0 and negative 2.14, I got to go to the table, and then I got to look for 2.1 on the side, and then I got to slide to the right 0, 1, 2, 3, 4. And I'm going to find there the probability of 2.14. So I'm going to go to 2.1 and then slide to the right to 4. So the probability of negative 2.14 is 0.4838. So probability of this is 0.4838. Good so far? All right. Now, unfortunately, that's not the question that they're asking us. The question that they're asking us is not just the probability between the center and 60, but the probability higher than 60. The good news is that we know that when we split a normal curve in half, this half is going to be 0.5. And since now we know that the probability between the center and 60 is that number, then the answer to my question is equal to the 0.5 that I know here plus 0.4828. And that gives me 0.9828. And that is the probability on this graph with these numbers that somebody scored higher than 60 on this exam. Probability is 0.9828. Alright. Hope you like the example. Let's move on to the next one. Okay, example number 3. What is the probability? That a student scored between let's call it between 70 and 85. Okay? So again, same mean, same standard deviation, different question. What's the probability that a student scored between 70 and 85? Always start with the graph, just very useful. Alright, now we know the center of my graph is at 75. And we know that the mean is 75, standard deviation is 7. The question is asking, what is the probability that somebody scored between 70 and 85? So, the question that we're being asked is, what's the probability that somebody score between 70 and 85? Now the first thing that we need to do is we need to find the z-values for that. We know that every time we do the mu and the sigma, mu will be 0, sigma will be 1. But we don't know these, so we have to calculate them. Now, the z of 70 is equal to 70 minus 75 divided by 7. So it's x, which is the number that we're trying to calculate now, minus mu, which is 75, divided by sigma, which is 7. Okay, and we're going to have negative 0.71. Okay, now the z of 85, because we need to find the z-value of this. This one is 0.71 negative. Now remember, the negative just means that you're left of the center. Z of 85 is 85 minus 75 divided by 7. I got 1.43. Got to round up on that one. Okay, 1.43. Now this 1.43 is there. So this is my z distribution. This is my normal distribution that I have here. Okay, now to find the probability, they're asking us for the probability of this portion here. Because they want to know what's the probability that somebody scored between 70 and 85. Okay, again, on the table that I have, and there are different tables out there that you can find, but in the one that I have, they're always giving me the probability between the center and the number. So it's always the probability between the center and whatever number you're looking for. That's what you're being given here. So when I take this negative 0.71, to find it, I got to go to 0.7 on the side and then slide to the right to 1. So I go to 0.7, slide to the right to 1. Probability is 0.2611. So probability of this area is 0.2611. Okay, now in order to find the probability for z1.43, I got to go to 1.4, slide to the right on 3 in the z table. So I'm going to go to 1.4 and then slide to the right to 3, and the answer is 0.4236. So 0.4236. Okay, now the question that they're asking us, it's neither one of those, but instead they're asking us of it together. They're asking us what's the probability that somebody scored between 70 and 85. But I know the probability between the center and 70, and I know the probability between the center and 85. So the answer is the addition of those two. So the answer to this question here, the answer is 0.2611 plus 0.4236. Okay, and that is 0.6847. So there is a 68% probability, or 0.68 probability, that a student scored between 70 and 85 in my example. Alright, I hope you liked my video on normal distributions and how to calculate a probability using a continuous probability normal distribution. Have a good one. See you later.